Hello people. In the previous video we have seen binary search algorithm and its implementation. In this video we will be seeing binary search implementation using recursion concept. It is a concept to solve complex problems by breaking them into simpler ones. Recursion is usually asked in competitive exams and interviews, so it is important to learn about it. So to start with the implementation, I will be first defining a function which will be named as binary search using recursion. Now this function is going to take 4 parameters. First is the array, second is the element to be searched, third is the low value, which is nothing but the position of the first element, and next will be the high value, which is nothing but the position of the last element. Mentioning low and high in the parameter list is beneficial. Now how it is beneficial? Let's see inside the code. Now here I have defined any random sorted array. Note that binary search works only for the sorted array. If you are not having sorted array, then you have to first sort it, and for sorting you have to check my playlist on sorting techniques. Now I'll be calling the function binary search using recursion with the parameter array that we defined now. Now let's say the element to be searched is 34340. Next, the low value will be 0 because array indices starts from 0, and the high value will be the last position which we can get from the length of the array -1. Now let's start writing the logic for the recursive code. First and foremost condition is that we have to check whether low is less than or equal to high. Obviously when low is greater than high, then the element does not exist inside the array. Hence, if this condition doesn't satisfy, then we will return that the element is not found. But if the condition satisfies, that means low is less than or equal to high, then we will now write the logic. Now, as per the algorithm, the first step is to find the middle element's position. Now to find the position of the middle element, we need to write a formula low plus high by 2. Here I am using floor division to avoid any unnecessary floating values. Now once we get the middle element's position, we will check that the element that is present on the middle position is equal to the element to be searched. If yes, then we will return that the element is found at index middle, because middle stores the value of the position of the middle element. Now if they are not equal, then we will check that the element to be searched is lesser than the element which is present on the middle position. Now in this case, the element to be searched will obviously lie on the left hand side of the middle position. That means we need to keep low as it is, and we need to change high to be middle -1. So now it's time to write the return statement. Now in the return statement, we will return the same function but with the different parameters. So here we want the array to be the same, so we will write ARR. Now the element to be searched will not change, so we will write the same. Now since the element is lying to the left of the middle position, so low will be as it is, and as I said that high will be now middle -1. Now the third possibility is that the element to be searched might be greater than the element that is present on the middle position. Now pause the video and try to guess what changes we should do in the parameter list while calling the same function in the return statement. I'm sure you have guessed it. Now let's see the solution. So now since the element to be searched is greater than the element which is present on the middle position, so obviously the element is lying on the right hand side of the middle element. So in that case, the low will become middle +1 and high will remain as it is. So now to summarize, first we have checked whether low is less than or equal to high. If yes, then we found out the middle element's position. Then we compared the middle element with the element to be searched. If they are equal, then we return that the element is found. If the element to be searched is less than or equal to element at the middle position, then we have changed the high value as middle -1. Otherwise, we have changed the low value as middle +1 by recursively calling the same function. So this is how we can implement binary search algorithm without using any loops. So I hope that you have understood the entire flow of the code. Now let's execute the code. And yes, we are getting the output that the element is found at index 7. Now just to check some validations, we will change the element to be searched now. So let's put any element which is not present inside the array. And let's check whether our code is able to handle it. So you can clearly see that the code displays the output as element not found. Find the entire code in the description box. Don't forget to like, share and subscribe to my channel. Thank you.